Okay, so we're ready to finish up Chapter 5. And as always, you should probably do the review for the chapter before you watch the video, and just use the video as just, confirming what you do know and like filling in the gaps of what you don't know. It's not probably the best to just watch the video like it's a lecture, because that's not how the test is going to be. So I'll just jump into this. And problem 1 asks me to solve by the square root property, and most of the problems are set up to solve by the square root property. To solve by the square root property, you square root both sides. You need plus or minus square root on one of the sides, and normally we put it on the side without the variable. And then on the left side here, square rooting cancels out the square. It leaves me just the y. And on the right side, I don't even need my calculator. I know the square root of 4 is 2. This would be perfectly great for an answer, or you can write y equal to 2 and negative 2, and that would be equivalently good. These are both completely acceptable answers. And that's all there is for that, just a nice baby-ish problem. For part B, because the square term isn't isolated, if I square rooted first, I might accidentally get the right answer, but probably not. You'd probably get an I in your answer. What you need to do in part B is make it look more like part A, with the square term on the left side and the number on the right side, and then you can square root plus or minus square root. On the left side, when you square root something squared, you just get the thing that was being squared. And then because 7 is a prime number, that square root doesn't reduce, and I don't really want decimal answers. So I'm going to leave my answer just like that. And again, I could, if I really care to, write k equal to square root of 7 and minus square root of 7. But that's really not any better and takes more work, and I had to write it twice. Part C, still I'm going to go square root plus or minus square root, and this one's ready for that because the whole left side is being squared. So I square rooted plus or minus square root. On the left side, the square rooting is going to cancel out the exponent of 2. It'll just leave me with the parentheses without an exponent, so then I won't need the parentheses anymore. And on the right side, the square root of 4 is 2. Because after the plus or minus sign there's not an I and there's not a square root, I'm going to expect to see 2 answers, and I won't expect to see a plus or minus sign in my answer. If after the plus or minus sign this 2 had an I, or if it had a square root, then I would leave the plus or minus sign in my answer. But in this case, the terms on either side of the plus or minus sign when I subtract 3 are like terms, and they can be combined, so I should make the 2 separate problems up. So again, if this was like 2i or 2 square root of 7, I would stop right here. I only make a separate problem, one with the plus, one with the minus, when both terms on the right side with the plus or minus don't have square roots. And so now I'm going to go negative 3 plus 2 and get negative 1, and negative 3 minus 2, because those numbers have the same signs, I add them and keep them negative. So here I'm writing my answers with 2 Q's. I'm writing a wrong answer because that should be negative 1. It's the problem with not using a calculator. Sometimes you just kind of do bad math in your head. And negative 3 plus 2, because the numbers had opposite signs. I knew I should subtract, but I should take the sign of the larger number, which just makes it a negative 1. So just to emphasize, I could write q equals negative 1 and negative 5 like that. If I wasn't being lazy and I went to check, I would have found out that 1 wasn't right. Like if I tried to check the answer that I put down, which was 1, I'd go 1 plus 3 squared equals to 4. This would give me 4 squared equals to 4, which is 16 equals to 4. So I know 1's not correct. If I wanted to check the negative 1, I'd go, is negative 1 plus 3 squared equal to 4? I could do that by hand, or I could do it on my calculator, and apparently my calculator is probably better than I am. So if I do negative 1 plus 3 squared, I'll get, you can't see it, but you get 4 equal to 4. And similarly, I could check negative 5. I could go q equal negative 5 and do negative 5 plus 3 squared equals to 4. And then on my calculator, I would just back up into the problem that I just did, get to the right of the 1, delete it, change it to the negative 5, and that gives me 4 equals 4 as well. So 1 is definitely not a correct answer because bad things happen when I plug it in, but negative 1 and negative 5 are correct because when I plug them in, I get a true statement. D is much nicer in that when I do the plus or minus square root on the right side, I'm going to have both an I and a square root, and having just one or the other is enough not to have to make a separate plus or minus. I mean, you'll leave the plus or minus in the answer. So when on the right side, when you're doing this square root method, if to the right of the equal sign, when you do that plus or minus, if you have either or both a square root or an I, you get to leave the plus or minus in your answer, and you don't make up the individual problems, one with the plus, one with the minus, like I did in the last problem. For this problem on the left side, when I square root, I'm going to get t plus 5. On the right side, I get a plus or minus sign, and I can reduce the square root of negative 18 pretty easy if my calculator is in complex mode, which it doesn't look to be, so I'm going to hit my mode button and type 2. And now I'm going to do square root of negative 18. And that gives me 3 square root of 2 times I, that after the plus or minus sign. And I could have reduced that in by hand real easy, because this square root of negative 18, you get an I because of the negative, and 18 is 2 times 3 times 3, which makes me get a 3 outside the radical and a 2 under the radical, which is what I got from my calculator. Without the plus or minus sign, I have to kind of insert the plus or minus sign myself. Now I'm going to minus 5 from both sides. I'm going to have my answer. So when on the right side of the plus or minus sign, you have a square root, an I, or both a square root and an I, then you leave the plus or minus in your answer. So that would be perfect for answer for part D, just number 1. Completing the square. This problem on the test, there's usually one of these, and it will, on the instructions for the test, it will say, if you solve this by factoring or the quadratic formula, you're going to get 0 points. So don't solve this by factoring or the quadratic formula. You'll get the same answers, the quadratic formula, factoring, and completing the square, all will give the same answers. Something tells me it's like a 7-point problem on the test. If on the test you solve the problem that's similar to this, that has the instructions solved by completing the square and you use the quadratic formula, or the factoring, and regardless of the answer you get, this is the only problem on the test that if you don't use the prescribed method, you're going to lose everything. So make sure to learn this method. It's not horrible, it's just lots of steps. So step 1 is to isolate the term without the letter, or we call it the constant term. Isolate the number without the letter. And that's not terribly hard to do. Sometimes it's already done for me, sometimes I have to do it like in this problem. In this problem, for my first step, to get the number without the letter to be by itself, I'll minus 8 from both sides, and that'll take me to m squared plus 6m equals negative 8. Now I'm going to add c to each side. So I get m squared plus 6m plus c equals negative 8 plus c. And now I need to replace the c with, in this case, half of 6 squared. It's always half the number in front of the first power term squared. Half of 6 is 3. 3 squared is 9. So I'm going to replace the c with 9. And then factor the left side. Simplify on the right side. The left side's nice, it only has pluses, so I know I get a couple of pluses. I don't need bottoms up because there's not a number in front of the m squared. And my lasts can either be 1 and 9 or 3 and 3 for that 9 to work out. And the 3 and 3 will help me get the 6. Always when you factor at this step and completing the square, you have to get two identical factors. And you should write them with a square as opposed to having those factors written twice. So that's factoring the left. Simplifying the right is numbers have opposite signs. You add or you subtract and take the sign of the larger. And now I'm going to square root slash plus or minus square root, just like the last few problems. So square root plus or minus square root. On the left side, when you square root something squared that's in a parentheses, you just get the contents of the parentheses. The square root cancels out the square. And on the right side, 1 is its own square root. If I did the square root of 1, my calculator will tell me that's equal to 1 without a square root. So this is going to be equal to plus or minus 1. Now I'm going to solve this just like the last few problems. I'm going to minus 3 from both sides, and I get m equals minus 3 plus or minus 1. I'm going to work my way up to this last little blank spot I have to finish this, because what I need to do now is go m equals minus 3 plus 1. I guess I could do it here. M equals minus 3 minus 1 to get my answers. My answer shouldn't have a plus or minus sign if the number after the plus or minus doesn't have an I or doesn't have a square root. So the first one, negative 3 plus 1, is going to give me an answer of negative 2 because those numbers have opposite signs. I subtract and take the sign of the larger. And then the next one's going to give me negative 4 because both the numbers are negative. I add the numbers and keep them negative. And that's the best we can do for that. And you have to do all these steps. If you don't have this blanked out, if you don't have this chunk of work and you have those answers, when you get gotten by one of those methods, you won't get any points on the test question. B's same steps, solved by completing the square. So I'm going to minus 6 from both sides to isolate the term that doesn't have the letter. So that's my first step, is to get the number that doesn't have the letter to be alone, usually on the right side of the problem. Step 2 is adding c to both sides. And then I'm going to find c. c is going to be half times 4 squared. It's always the number in front of the letter without the exponent. Half of 4 is 2, and 2 squared is 4. So now I'm going to write this as p squared plus 4p plus 4 equals negative 6 plus 4. I'm going to factor the left side. I know I get a couple of p's, and nicely on the left side I don't have any minuses, so I know I need a double plus. And then for my lasts, they're either going to be 1 and 4 or 2 and 2 because they have to multiply to be 4. The 1 and 4 add up to 5, so they're not going to work. The 2 and 2 add up to 4, they are going to work. And I'm going to write the left side as p plus 2 quantity squared. On the right side, the numbers have opposite signs, so I subtract and take the sign of the larger, and I get a negative 2. Once I get it like this, then I solve it like the problem 1. Square root plus or minus square root. The p plus 2 squared, when you square root it, you get p plus 2. The other side, you get plus or minus the square root of 2, and then I'm going to make an I come out to make the square root have a positive number under it. The nice thing is, if there's one or both, a square root and an I, the plus or minus is going to stay in my answer. So I expect a plus or minus in my answer, and now I'm just going to minus 2 from both sides. And that's going to lead me right to my answer. I'm going to write p equals minus 2 plus or minus the square root of 2 times I. And the I shouldn't be under the square root, it's after the square root. The next two problems are quadratic formula. You can definitely use your calculator to do the quadratic formula. I'll do this by hand. For me, the A is going to be 5. The B is going to be negative 14. The C is going to be negative 3. And it's a dumb letter to use B, but I'm going to write B equals and make my fraction. And then the formula has negative B, which is going to be negative of negative 14, plus or minus the square root of B squared. Because B is negative, it has to be in a parentheses. And then minus 4AC, which is minus 4 times 5 times negative 3, all over 2A, so all over 2 times 5. So this is going to give me the two negatives there make a positive. And then under the square root, I think negative 14 squared, I think it's 196, but I don't know that for a fact. So I'm doing negative 14 squared on my calculator, and it is 196. So under the radical, you get 196. The double negative here is going to be a plus. I'm going to do minus 4 times 5 times minus 3. And I get a positive 60 for the other part of what's under the radical. Just so hard to let you see that. So under the radicals, 196 plus 60, which is going to be 256. So on my next step, under the radical, I'm going to write a 256. And then I'm going to write a 10. I'm going to let my calculator reduce the square root of 256. I think it's perfect if I do it right. Square root of 256 is, can't see it again, is 16. When the square root goes away, you should make a separate problem, one with a plus, one with a minus. And I'll do that here. I'm going to go B equals 14 plus 16 over 10, and B equals 14 minus 16 over 10. The 14 plus 16 is 30. And 30 over 10 is 3. The 14 minus 16 is negative 2. And negative 2 over 10 reduces to negative 1/5. So that's doing it all by hand. That's the safest way to get partial credit. Quite honestly, I don't care if you just get the 3 and the negative 1/5 on your calculator, as long as you show this line here. So if you just went from this line to the answer, I'm completely content with that. And I'll show you how to do that just in case you don't remember. So on my calculator, to do it by hand, I'd go fraction, negative, and then parentheses, negative 14, plus square root, parentheses, negative 14, parentheses, squared. And then minus 4, parentheses, 5, parentheses, negative 3, all over 2 parentheses 5. This is only going to give me one of the answers. It gives me the answer of 3 that I got. And now to get the answer of negative 1/5, I just simply hit my left replay button, get into the problem, get my cursor flashing right to the right of the plus sign, hit delete, change that to a minus sign, hit enter, and it gives me the negative 1/5. So I'm completely content with you doing it on your calculator. In fact, I would suggest you doing it both ways, because if you get the same answer by hand as you did on your calculator, then it almost has to be right. For part B, I'll do it by hand and on my calculator again. For part B, the A is going to be 2, the B is going to be 3, the C is going to be negative 7. I'm going to go negative B, which is negative 3, plus or minus the square root, I should probably write T equals, and then negative 3 plus or minus the square root of B squared, which is 3 squared, minus 4AC, which is 4, times 2 times minus 7, all over 2A, which is 2 times 2. Notice when the B is positive, I don't have to put it in a parentheses. Under the radical, 3 squared is 9, and here this is negative 4 times 2 is negative 8, negative 8 times negative 7 is positive 63? No, not positive 56. So under the radical, I'm going to get 9 plus 56, which is 65. It's a really nice number to get under the radical. So now I'm going to get negative 3 plus or minus the square root of 65 over 4. 65 I don't think is a reducible square root. If I try to reduce the square root of 65, I just get the square root of 65 back because it's a non-reducible square root. If the square root doesn't reduce or doesn't go away, you'll leave the plus or minus in your answer. You won't make up separate problems, one with the plus, one with the minus. That's going to be the whole answer. When I do this on my calculator, I can get the answer with the plus, and I won't even have to do it with the minus. So let me do this on my calculator now. So fraction negative 3 plus square root 3 squared minus 4 parentheses 2 parentheses negative 7 all over 2 parentheses 2. Looks close enough to the original. And I get almost exactly what I have, other than it doesn't have the plus or minus sign. If I wanted to confirm, if I change the plus sign to a minus, that I get the minus part of this, I just go back to the problem, get to the next to the plus sign, delete the plus, put a minus in, and hit enter, and the other answer. It factors it strangely, which I don't like, but this negative means negative. The negative just means take the opposite of the numerator. The opposite of positive 3 is negative 3. The opposite of plus is minus, and it means negative 3 minus the square root of 65 over 4. I wish your calculator wasn't programmed to write the answers that way when you get the two negatives in the numerator, because the two answers are negative 3 plus the square root of 65 over 4 and negative 3 minus the square root of 65 over 4. And my calculator factors out a negative there. When you factor out a negative, you write the opposite. The opposite of negative 3 is positive 3. The opposite of negative is positive. And that's what my calculator just showed. And that's because it's the same as that. I like this version better. But if you wrote this for an answer and that for an answer and didn't use the plus or minus sign in your answer, I don't have a problem with that. It's just kind of a clumsy way to write the answer. C is a problem where the students that kind of are the C students in class are going to miss points. Not so many of the A and B students will fall into this trap, but every semester I put a problem like C on the test, and I'll make a note, as I'm doing this video. You gotta have the problem set equal to 0. If the problem is not set equal to 0, you have the wrong signs for your letters. So the quadratic formula that we were using for this problem absolutely requires the problem to be set equal to 0. Wish I could spell, but sorry about that. If you don't set it equal to 0, you won't get the right answer. So for one problem on the test that kind of mirrors this problem, that's not set equal to 0, and you're asked to use the quadratic formula, what you're going to have to do is get everything on the same side of the equal sign. Completing the square requires the number without the letter to be on the opposite side. The quadratic formula requires everything to be on the same side. Now I'm ready for the quadratic formula. I'm going to go A equals to 12, B equals to negative 5, C equals to negative 2. Now I'm going to go X equals fraction negative B, which is negative 5, plus or minus the square root of B squared, which is negative 5 squared, minus 4AC, which is 4, times 12 times negative 2, all over 2A, which is 2 times 12. In the numerator, this double negative turns positive. And then negative 5 squared is positive 25. And this is negative 4 times 12 is negative 48 times 2 is positive 96. I better make sure of that. Negative 4 times 12 times negative 2. And I get positive 96. And then 25 plus 96 under the radical is 121. So for the by hand, more or less by hand, I'm going to write 121 under my radical, 24 in the denominator, and then 121, the square root of 121 is 11. Because the square root went away, I don't want to have a plus or minus in my answers. So I'm going to make up the two problems that are implied by the plus or minus, which are 5 plus 11 over 24 and 5 minus 11 over 24. 5 plus 11 over 24 is 16 over 24, and that reduces by 8. 16 divided by 8 is 2. 24 divided by 8 is 3. And I'm going to get x equals 2/3 for one of my answers. And this next one, 5 minus 11 is negative 6. And negative 6 over 24 reduces by 6. Negative 6 divided by 6 is negative 1. 24 divided by 6 is 4, and my other answer is going to be negative 1/4. Probably way better to do this just without doing it by hand, so now I'm going to do that by hand. I'm going to enter that just like that, the best I can. So I'm going to go fraction negative parentheses negative 5 parentheses plus square root parentheses negative 5 squared minus 4 parentheses 12, parentheses negative 2, all over 2 times 12. That gives me the 2/3 that I got by hand. Need to get back into the quadratic formula, and I need to change the plus sign outside in front of the radical to a minus, and it gives me the negative 1/4. So I'm 100% sure now that I did it right. I did it 2 different ways and got the same answer, but if you had left the 2 and made the c equal to positive 2, you'd get the wrong answer to this. Okay, 4 is the only problem on the test where you absolutely have to check the solutions. And I can tell it's different than every problem on the test. Well, is it? Because it has a square root in it. And I don't think any of the other problems, problem 1, it had a square but didn't have a square root in it. B of 1 didn't have a square root. They have squares which aren't square roots. As I look at every problem that I've done so far, I don't see any square root symbols. So I just kind of flipped through the half-dozen problems that I've done. I say lots of squares but no square roots. When a problem has a square root and an equal sign, there's possibilities of getting solutions that don't check. This is the only time that you need to check. So I'm going to solve this how we solved it in class. First thing I'm going to do is isolate the best I can the 3 square root of p by minusing p from both sides. In general, you want to get the square root term by itself the best you can. When I minus p from the left side, I'm just left with the 3 square root of p. And on the right side, I'm left with minus p and plus 4. Or you could write p minus 4. That's the first step. Now I'm going to square both sides. And it's a little bit trickier on the left side because of that 3 outside the radical. And the right side is a little bit tricky because you have to FOIL. The difference between the left and the right side doesn't have any adding, so you could just square each piece. The right side has the addition sign between the terms, which forces me to FOIL to square it. So on the left side, I square the 3. 3 squared is 3 times 3, which is 9. And I square the p, the square root of p, and square rooting cancels out a square root sign, and it leaves me just the thing that was being squared. On the right side, I do firsts are negative p times negative p, which is positive p squared, and then outers are negative p times 4, which I'll write as negative 4p, and then inners are 4 times negative p, which I'll write as negative 4p again, and last, which are 4 times 4, and I'll write that as a plus 16. I'm almost to the point where it's going to be easy. The outers and the inners don't cancel, they have the same signs. So I'm going to add the 4's and keep them negative and get a minus 8p. So now I've squared both sides, and now I'm going to set equal to 0 and solve by factoring. And so I'm going to minus 9p from both sides, minus 9p. On the left side I get 0, and on the right side both the p terms have the same signs, so I'm going to add them and keep them negative. And then it's just a matter of personal preference. At this point you can solve by factoring, or you could use the quadratic formula. I factor pretty well, so I'm going to solve this by factoring. If you didn't know how to factor this, then you could use the quadratic formula. I know the signs are double minuses. I don't need bottoms up because there's not a number in front of the squared term. So I can pick a minus 1 and a minus 16 for my lasts in the factoring, a minus 2 and a minus 8, or a minus 4 and a minus 4. It's the minus 1 and minus 16 that are going to be the pair that give me the minus 17. And then I'll go p minus 1 equal to 0 and get p equal to 1. And p minus 16 equal to 0 and get p equal to 16. Have to check them both in the original problem. If I don't check and I write both these down, I'm probably making a mistake. So the first checking I'm going to do, I'm going to go 1 plus 3 square root of 1 equals to 4. And the second checking I'm going to do is 16 plus 3 square root of 16 equals to 4. Do them both on my calculator just because it's probably easier. So first one, 1 plus 3 square root of 1. That gives me 4 equal to 4. So 1 is a solution. When I do the other side, 16 plus 3 square root of 16, which you can't see, you get 28. And 28 doesn't equal to 4. So the only answer, the only one I'm going to write, is p equal to 1. So if this was a test question and you did all this beautiful math and you got lazy and didn't check, you'd lose probably 2 points for writing down a solution that doesn't check. So it's a pretty involved problem. It's the most involved problem on the test. And there's guaranteed to be one of them. So B, I can do 2 ways. I can do with use substitution, which is likely easier, or I can just brute force multiply it out. And I hate doing multiple ways. When I grade tests, most students do the brute force multiply it out rather than the use substitution. So that's what I'm going to do. If you did it by use substitution and get the same answer, then you've done it right. If you like use substitution better, you tried it and didn't get the right answer, then send me what you have and I'll fix it up for you. So I'm just going to just really go through just the pain of this to get it done right. And the pain of this requires me to get rid of that exponent first. And to get rid of that exponent, it's going to require a lot of multiplying and I'll get some big numbers. The first thing I'm going to do is I write the problem without the exponent, and now I'm going to multiply the 2 into the parentheses that it's next to. So I'm going to go 2 times 5x and get 10x, 2 times 3 and get a positive 6. Now I'm going to FOIL. First are 10x times 5x, which is 50x squared. Outers are 10x times 3, which are positive 30x. Inners are 6 times 5x, which is a positive 30x. And the lasts are 6 times 3, which is a positive 18. So I've done the exponents. I'm going to combine the outers and the inners and get 50x squared plus 60x plus 18. And now I'm going to get rid of that next parentheses. That parentheses has a minus in front of it, so I need the opposite of the parentheses. The opposite of positive 5x is negative 5x. The opposite of positive 3 is negative 3. Now I'm going to combine like terms. The 50x squared has nothing to combine with, but the plus 60x and the minus 5x need to be combined, as do the plus 18, minus 3, and minus 28 need to be combined. The 60 minus 5x is 55x, and 18 minus 3 minus 28, just so I don't mess it up, 18 minus 3 minus 28 is negative 13. Whoa. This probably factors. No way in heck I'm going to try to factor it. I'm going to use a quadratic formula. I'm going to go A equals 50, 50, B equals 55, C equals minus 13. Let me just, I'm going to look at my work for a second here. Looks right. And now I'm going to break into the quadratic formula. So negative B, which is negative 55, plus or minus the square root of b squared, which is 55 squared, minus 4ac, which is 4 times 50 times negative 13, all over 2a, which is 2 times 50. No desire to do this without my calculator, so I'm going to break my calculator out and figure out what this equals to. So best I can now, fraction negative 55 plus square root 55 squared minus 4 parentheses 50 parentheses negative 13 over 2 parentheses 50 gives me 1/5. Beautiful. And now I'm going to back up, change that plus sign to a minus. Takes me a long time to get there, but I'll eventually get there. There's got to be a quicker way. And I get negative 13/10. So if you did it using another method and you got those answers, then I feel good about those answers. I can check them in my head real quick. Boom, boom. That's good to me. 16, 32, 4. Perfect. I checked the 1/5 in my head. I'm assuming negative 13/10 also works. C, I could also do use substitution, or I could just get rid of the parentheses. I'm just going to get rid of the parentheses because that's what most students cling to, because it's kind of just known to them. Use substitution is probably easier, but it's a pretty slick trick. So I'm going to clear the parentheses just like I did in the last problem. I'm going to FOIL the squared. The first are x times x, which is x squared. The outers are x times 4, which is plus 4x. The inners are 4 times x, which is plus 4x. The last are 4 times 4, which is plus 16. And then I'm going to clear the next parentheses. I'm going to go minus 8 times x and get minus 8x, and minus 8 times 4 and get minus 32 equals to 12. So all my parentheses are gone. Oh, it's a trick problem. I get x squared plus 4x plus 4x minus 8x plus 16 minus 32 equals to 12. So these terms actually wind up canceling, because 4x plus 4x is 8x, and 8x minus 8x makes the x's cancel out. These terms, 16 minus 32, give me a negative 16. So this gives me x squared minus 16 equals to negative 12. Two ways to solve this. I could move the 16 over to the right and solve by square rooting, plus or minus square rooting, or I can solve by factoring by adding 12 to both sides. And I would guess that most students would do this because that's what they're used to doing. So that's what I'll do. If you added 16 to both sides and got x squared equals to 4 and you square rooted and plus or minus the square root, you'd get the same answer. I'm going to do this by factoring. That's the difference of squares, which gives me x plus 2, x minus 2. When I do x plus 2 equal to 0, I get x equal to negative 2. When I do the x minus 2 equal to 0, I get x equal to 2. 6 minus, really, I'm going to check this really quick. So I'm going to check the 2 because I'm trying to check it in my head and it's not working. So it does 2 work. Does 2 plus 4 squared minus 8 times 2 plus 4 equal to negative 12? I don't know. So always can check anytime I have an equal sign, and I kind of check in my head, even though if I don't show the checking, just the best I can. And then sometimes I mess up checking in my head, and that's what happened here probably. Because when I put 2 in, you get negative 12 equal to negative 12. When I put negative 2 in, I just go back to the line that I just did, put a negative in front of the first 2, put a negative in front of the second 2, and you get negative 12 equals to negative 12. So I've checked them even though I don't have to check them. I just wasn't sure it was right. Another one of these, but a super friendly one, I put this on every test. This one we solve by factoring. The quadratic formula does not work when you have an x to the fourth. So 2 things the quadratic formula needs. Won't work if it's not set equal to 0, like a few problems back. And it won't work when there's an x to the fourth. So I'm just going to factor this. I'm going to divide the exponent of 4 by 2 and get a couple of x squareds for my firsts. My template tells me these are a couple of minuses, and my lasts are either going to be -1 and negative 4, or -2 and negative 2. The negative 2 and negative 2 doesn't give me that negative 5, so I'm going to put the -1 and negative 4. Forgot the equals 0 part. So interested in putting this other stuff. So now I could factor more, or I could set each of the factors equal to 0. There's lots of ways to go about getting from this step to the answer. You can factor those, or you can solve them by adding the numbers and square rooting, plus or minus square rooting, just to show you that other strategy. I'll do the square rootings plus or minus square rooting way to solve these. You'll get the same answer if you factored though. So I took the factors and set them equal to 0, added the number to each side. Now I'm going to square root plus or minus square root. Square root of x squared is just x. Square root of 1 is just 1. Square root of x squared is just x. Square root of 4 is 2. That's going to be my answer, plus or minus 1 and plus or minus 2. Still feels like I've got a pretty good chunk of problems left, so we'll just keep going at this. And I'm going to use my calculator and exploit it to make the table. Remember that when I'm graphing a parabola, if there's a parentheses, I take the number in the parentheses, change its sign, put it in the middle of my x column for my table, then I go smaller a couple and bigger a couple. And now I'm going to just use my calculator to get the y's. So mode 7 for table, and then parentheses alpha x minus 2 squared plus 3. Oh, bad. I don't know what happened, but I'm in a bad mode here. I have to go shift, set up, down, 5 for table. Somehow I got into the second mode where I had f of x and g of x. I have no idea. I didn't do that as accidentally. It just happened. So I changed it to mode 1. So I did second, set up, went down to option 5 for table, select number 1. I think it'll let me enter the table now. So parentheses alpha x minus 2 squared plus 3, start at 0, end at 4, step 1. First point is supposed to be 0, 7. Second point is the point 1, 4. Third point is the point 2, 3. Then the point 3, 4. And then the point 4, 7. You can tell that you have a nice table if you get that nice duplication in the y's. I don't have graph paper, but I don't really need it. I need to get up to 7 on the y-axis. Might need to go higher than that. And I need to go out to 4 on the x-axis. And the best I can, I'll plot the points. So then my first point's the point 0, 7, which is that right there. And then 1 and 4 is about there. And then 2 and 3 is about here, which is the vertex. And then 3 and 4, and 4 and 7 the best I can. So I've sketched a graph, but I haven't labeled the vertex or the axis of symmetry. The axis of symmetry always has the equation x equal the x coordinate of the vertex. So I'm going to get x equal to 2 for the axis of symmetry, and the vertex is always in the middle of my table. That's everything. Getting the y's by hand just takes too long, and it's not really a productive thing to do. For 5b, again, it's a parentheses problem, and it's a parabola graph, so I take the number inside the parentheses and change its sign, and then go smaller, -4, -5 are smaller, bigger are -2 and -1. Now I'm going to get my table, so mode 7 for table. If I had a g of x there, then I would have to do something, and if you have that come up on the test, I'll fix it for you. So parentheses alpha x plus 3 squared, that's the whole function. And then start at -5, end at -1, step 1. The first point is the point -5, 4. The second point is the point -4, 1. The third point is the point -3, 0. Then -2, 1. And -1, 4. Again, if you get that lovely duplication in your y's, you know you have a good table. So I need to get out to -5. So -1, -2, -3, -4, -5. I only need to get up to 4. First point, -5, comma 4, it's kind of about there. And then -4, 1 about there. -3, 0, -2, 1, -1, 4. Plot the points, connect them with a U. That right there is my vertex. My vertex is always in the middle of my table. My vertex is the point -3, 0, and the axis of symmetry that this also asks for always is x equal the x coordinate of the vertex, which is -3. Both parts of 6 wants me to just sketch a graph and for the number and find the vertex. So for the number in the middle of the x column, because there's 2 x's, for the number in the middle of the x column of my table, I have to use a formula when there's 2 x's. When there's 2 x's and no parentheses, I need that formula. It's not a hard formula because it's kind of part of the quadratic formula. The formula for the middle of the x column is -b over 2a, and in this problem the a is 1 and the b is 6 because the a is the number in front of the x squared. So -b over 2a is going to be -6 over 2 times 1, which is going to be -6 over 2, which is -3 again. So in the middle of my x column, I'm going to plug the number -3, and then I'm going to also put in -4, -5, -2, and -1. Now I'm going to get my y's, going mode 7 for table, f of x equals alpha x squared plus 6 alpha x plus 10. Start at -5, end at -1. Step 1. First point's the point -5, +5, then -4, 2. The vertex -3, 1, then -2, 2, and -1, 5. Plot those points the best I can. It doesn't really have to be that great. Again, I need to get all the way out to -5 on my x-axis. Don't really even need the positives. I didn't write them because I don't need them. I need to get up to 5 on my y-axis. First point, -5, 5 is -5, 5, and then -4, 2, -3, 1, -2, 2, -1, 5. The best I can. I plot the points. They should make some sort of U. I'm asked to find the vertex, not the axis of symmetry. I don't ask anything about maximums or minimums on the test. So this is all you're responsible for, the problems that have the two x's. Figure out what table works, sketch the graph, and give me the vertex. Doesn't say for what values of x is the or maximum or minimum value. That stuff doesn't come up. 6b, same sort of problem. So for the number in the middle of my x column, I'm going to use -b over 2a. And in this problem, a is -2 and b is -12. So I'm going to get -b, which is -12, and 2a is 2 times -2. This is going to give me a +12 over a -4, again a -3. Oh well, it is what it is. So -3, -4, -5, -2, -1. 3 times in a row. That's just a coincidence. Doesn't hardly matter when I'm working with my calculator. So table on my calculator now, mode 7, and then -2 alpha x squared minus 12 alpha x minus 19. Start at -5, end at -1. Step 1. First point is the point -5, -9. Second point is the point -4, -3. And then -3, -1. And then -2, -3. And then -1, -9. I'm not really liking to plot this, but I'll deal with it. So best I can, I need to make my graph kind of bottom heavy. So I'm going to make it look like that. So this is my y-axis, this is my x-axis, then -1, -2, -3, -4, -5, and now all the way down to 9. 1, 2, 3, 4, 5, 6, -7, -8, -9. First point, -5 on the x-axis, -9 on the y-axis, then -4, -3, and then -3, -1, -2, -3, -1, -9. It's good that it's upside down because when there's a negative in front of the x squared term, it's upside down. So there's my graph. The only thing I'm asked to talk about is the vertex. If you give me the axis of symmetry or say anything about maximums or minimum values, it's fine. I just don't want them, but you can give them to me. I won't take points off. It's the end of graphing. Now we go to the word problems. And in both the word problems, the really only thing you need to do is find the vertex and know what the vertex is going to give you. And it will answer all the questions that we need. So in this case, if I look at the equation, there's two letters. There's the letter t, which is kind of in the x position, and that gives me the time after the ball is thrown. And h gives me the height. if I want to, I can make a table for this graph. Maybe it'll help you understand it better. And my table is going to look like this. The x column I'm going to call time. The y column I'm going to call the height of the ball. And to get my table started, I'm going to go negative b over 2a. And in this case, a is negative 8, b is 80. So I'm going to get negative 80 over 2 times negative 8. I want to do that without my calculator. Go mode 2 for complex. Fraction negative 80 over 2 times negative 8 gives me 5. So in the middle of my table, I'm going to put 5. Then I'm going to go 4, 3, 6, 7. Now I'm going to graph this, or get the table. Mode 7 for table, and then negative 8. I can't do a t, so I'll do an x squared plus 80x plus 20. Start at 3, end at 7. Step 1, I get at 3 seconds, the ball's 188 feet. At 4 seconds, the ball's at 212 feet. At 5 seconds, the ball's at 220 feet. At 6 seconds, it's going back down to 212 feet. And at 7 seconds, it's back down to 188 feet. So I really only needed to find the vertex, but it's so easy on my calculator to get a nice table. The answer is going to be right here for both parts. Because the t is in the x position, the time is in the x column. Because the h is in the y position, the h stands for height, the height is in the y column. When does the object reach the maximum height? At 5 seconds. What is the maximum height? 220, and the units are feet. So really no algebra for these word problems. They're kind of friendly word problems. Do the same thing for number 8. 8 has this lovely problem that 1 stands for January, 2 stands for February, 3 stands for March, and so on. And I have the equation T of m, the temperature for the month, is negative 1 m squared plus 14m plus 42. And I'm going to make a table again. The x column is going to stand for the month, where 1 stands for January, 12 stands for December, 6 stands for June, 8 stands for August. And then the y column is going to be the daily high temperature, the average high temperature during that month. Now I do the same thing. I'm going to make a table, and I'm going to use negative b over 2a. The b is 14. The a is negative 1, so negative b is going to be negative 14. 2a is 2 times negative 1, so it's going to be negative 14 over negative 2, which is 7. 7 stands for July. Then I'm going to do June, May, August, September. Fill in my table pretty quickly now by going mode 7 for table. F of x equals negative 1 alpha x squared plus 14 alpha x plus 42. Start at 5, end at 9. Step 1. Average high during May is 87. Average high during June is 90. Average high during July is 91. Average high during August is 90. Average high during September, 87. And now I'm going to answer the question. The vertex is going to have my answer. The vertex is in the middle of my table. What month has the highest average temperature? That's July. That's the 7th month. What's the average temperature? It's 91 degrees. I'm assuming it's Fahrenheit. That would be insane in Celsius. 2 more problems, I believe. 4 more problems, I believe. And one of them I'm going to change before you even see it. In fact, one of them I'm just going to delete. I'm just going to do 9A, B, and C, and we won't even see a D. So how did we solve these problems in section 5-6? First, solve with the less than or equal to changed to an equal. So I'm going to solve x squared equals 64. I'm going to square root plus or minus square root and get x equals plus or minus 8. And then we have the number line that we create with negative and positive infinity as well. So my number line is going to go negative infinity, negative 8, positive 8, positive infinity. Create the intervals. The intervals are going to get square brackets on the 8s because of the or equal to. So negative infinity to negative 8, negative 8 to 8, and 8 to infinity. If you wanted to gamble, it's a less than, so the middle interval should be the right answer. I do that. I'll do it all the way out so I can be sure. I'm going to write my intervals down. First interval is negative infinity to negative 8. Second interval is negative 8 to positive 8. Third interval is 8 to infinity. Now I need my check number. I'll call it a test number just to be different. This interval I'm going to put a negative 9. The 0's in this interval, so I'll put a 0. That interval I'll put positive 9. And I need to check it into x squared is less than or equal to 64. First one, I'm going to go negative 9 squared is less than or equal to 64. That's going to say 81 is smaller than 64. That's false. The next one, I'm going to do 0 squared is less than or equal to 64. That says 0 is smaller than 64, which is true. And the last one, you do 9 squared is less than or equal to 64. That tells me 81 is smaller than 64, and that's false. And my answer contains the true intervals, so my answer to this is just going to be the interval from negative 8 to 8. And I could have, I can't even spell answer, but I could have done that without doing the whole table, because for us, unless it was a special case, of which there won't be any on the test, for less thans you get the middle interval, for greater thans you get the outside intervals. I'd probably gamble on that to save some time. Do the same thing for part B. It should be the middle intervals again. So I'm going to solve it like there's an equal sign. Go x squared plus 3x minus 18 equal to 0. Factor this, x plus 6 times x minus 3 equal to 0. Then go x plus 6 equal to 0, which gives x equal to negative 6. X minus 3 equal to 0 gives x equal to 3. Make my number line negative infinity, negative 6, positive 3, positive infinity, no or equal to, so all round brackets, negative infinity to negative 6, negative 6 to 3, 3 to infinity. Table now. Again, that's kind of optional, but if you're going up to calculus, you'll do something just like this, and you won't be able to fudge on the table, so it's good practice. Next column's the number in the interval. First one, negative 7, is kind of a nice number in this interval. Middle one goes from negative to positive. I pick the 0, and the last one I'm going to pick 4. Now I'm going to take the original problem, x squared plus 3x minus 18 is less than 0, and first go negative 7 squared plus 3 times negative 7 minus 18 is less than 0. Calculator time, and gotta go mode 2 for complex, and then negative 7 squared plus 3 times negative 7 minus 18. I get 10 is smaller than 0. That's not true. For the next one, I'm going to go 0 squared plus 3 times 0 minus 18 is smaller than 0. So that's going to give you minus 18. So I'm going to change these 7's, minus 7's, to 0's. and do that, and I get minus 18 is smaller than 0, and it certainly is smaller than 0, so I'll put a true. And then the last one I do is 4 squared plus 3 times 4 minus 18 is less than 0. So I go back into this table, or to this calculation, delete the zeros, change them to a 4. And I get 10 is less than 0, and that's false. So my answer for part B of number 9 is the middle interval. Round brackets only because you don't have the or equal to. The answer is going to be the interval from -6 to +3. Last problem. It's a greater than, so I expect the top and the bottom interval and not the middle. Solve it like there's an equal sign. X squared plus 5x minus 6 equals 0. No funky square roots or anything on the test. No special cases where you don't get a solution on the test. So I factored it. I get x plus 6 equal to 0, which gives me -6 for the number line. X minus 1 equal to 0 gives me 1 for the number line. And then I go negative infinity, -6, positive 1, positive infinity. First interval, negative infinity to -6, square bracket on the -6 because they are equal to. -6 to 1, double square brackets, and 1 to infinity. Infinities always get the round brackets. For my table, I'm going to go interval. First interval is negative infinity to -6. Second interval is -6 to +1. Third interval is 1 to infinity. My test number in the first interval should be -7, but you can pick another. The middle interval goes from negative to positive, so I check 0. The bottom interval, I'm going to check 2. I'm going to check them into x squared plus 5x minus 6 is greater than or equal to 0. First one, I'll go -7 squared plus 5 times -7 minus 6 is greater than or equal to 0. Break out my calculator, so parentheses, -7 squared plus 5 times -7 minus 6. This gives me 8 is bigger than 0, and that's true. The next one, I'm going to go 0 squared plus 5 times 0 minus 6 is greater than or equal to 0. So I'm going to change those -7s to 0. And I get -6 is bigger than 0. And a negative number is not bigger than 0, so that's false. And the last one, I go 2 squared plus 5 times 2 minus 6 is greater than or equal to 0. So I'm going to get to my calculator. I'm going to change the zeros to 2. And I get 8 is greater than or equal to 0, which is true. My answer is going to be the 2 true intervals. And usually when you have 2 intervals, you separate them by a union. So my answer to 9C is going to be the interval from negative infinity to -6, and then again the interval from 1 to infinity. Round brackets on the infinities, they always get round brackets. The square brackets on the numbers that aren't infinity because they are equal to. So that's everything. As always, I've got ample time to help you out. If you don't completely understand everything that I did, you got to get it understood before you take the test. That's the only way you're going to do really well on the tests. And then this is our second to last chapter. The last chapter we have left is chapter 7. I hope it's an easy chapter. I know it's a short chapter. There's only 3 sections in it, so it should be hopefully easy to get a good grade on that.